Hello, everybody. I will start my today with another live coding session. So today I solve this question: interval list intersections. You were given two lists of closed intervals: first list and second list, where first list is start end and second list J is start J and J. Each list of intervals is pairwise disjoint and in sorted order. Okay, so they're not connected. You see. Returns the intersection of these two interval lists. A closed interval AB with A smaller than or equal to B denotes the set of real numbers X with A from A to B. The intersection of two closed intervals is a set of real numbers that are either empty or represented as a closed interval. For example, the intersection of 1, 3 and 2, 4 is 2, 3. Okay. I see. So let me clarify my understanding first. So in this question, I'm given two lists. The first list, which is the 2D array because it's the list of intervals. And I will be given second list, which is also the 2D array because this is the list of intervals. And I will return the intersection intervals, which is the 2D list, obviously. Okay, good. So this is the interface of the method I will implement. And as the constraint, I can say the intervals are sorted in each of first list and second list. And also in each of first list and second list, each interval is disjoint. So it doesn't contain something like 1, 3, and 2, 4 in a single list, or 1, 2, and 2, 3. It's not included. Okay. Good. So let me take a look at examples. So first list, let's say something like 1, 2, and let's say it's 1, 2, and 4, 6, and 7, 8. And also, let me do it in this way. Let's say I'm given 2 to 5 and 6 to 9. So in this case, I should return 2 to 3 because I will be returning the intersection intervals. 2, 3, and 4, 5, and 7 to 8. So I will return this. Good. Okay, so that being said, let me think how I can answer this question. So the brute force approach is, let's say I use the 2 pointers. So firstly, I can say for the first, this is I1 and I2. Here I can say I1 is smaller than I2. Sorry, I mean I1 interval I1 ends before I2. So I take a look at these intervals and I take the intersection to 3. Then I move I2. And now I can say I1 finishes earlier and they don't have any intersection. So I move I1 to here. Again, it doesn't contain any intersection and I move the I1 again. And now it's here. So now I can find that they have the intersection and the intersection is 7 to 8. So I append this to the returned list and I move I1 because I1 ends earlier. Now, because I1 is finished, it's the end. So I finish the 2 pointers. Yep. So in this way, yeah, I think I can solve this question. And probably this is the best achievable time because at least I have to take a look at each list. I mean, in the, I mean, in each of first list and second list. So it should take at least n1 plus n2 time complexity, assuming that there are n1 intervals in the first list and n2 intervals in the second list. So this is the best achievable time complexity. Okay. And let me clarify which pointer to be moved again. Oh, and for space complexity, by the way, this should be constant. I don't need any data structure aside from the return list. Okay. So let's say I have this and this. In this case, after I compare this, okay, so the problem here is, let's say like this. In this case, I2 ends earlier, so I should move the I2 because there could be some more, some other, you know, interval which intersect with I1 intersects interval. But if I move I1, obviously I cannot find it. So in which interval ends earlier. And in the case they end at the same integer, it doesn't matter which I move because after moving it, definitely this one, in this case I1, finishes after I2, so I move I2. Vice versa. So in the end, I move I1 and I2 in the next 2 steps. Okay, so that's the basic approach. So let me start the implementation. But let me say, if first list is empty or second list is empty, I should return immediately empty list because there's an intersection. And pointing to I1 here, or I2 here, this is pointing to the non-existing element, so I have to take care of it. So as long as both of them are in the valid range, I compare this and takes the intersection. So take intersection and push to intersections, and then here, as I said, I compare the end of two intervals. And if I1 finishes earlier than I2 interval, or maybe if they finishes at the same time, I move I1. Otherwise, I move I2. Okay. And in the end, return intersections. Okay, so from here, I will try to take the intersection, the remaining part in line 44. So when I have the two intersections, so two intervals, this begins from the later start and ends at earlier end. So I will take it. And I have to take care if this doesn't have any, um, valid number range, I shouldn't include it. So in this case, intersection exists. So I append it. Yeah. Okay, so this is it. Just in case, in the case like this, start is here and end is here. And because start is equal to end, I don't find any intersection. Or in this case, I can say intersection begins at here and ends at here. And because of in line 14, the condition in line 49, this is not appended to the intersections as I expected. Okay, so now I'm done. So let me quickly dry run my code. So I will go with very simple case. Like this. 1, 3, and 2, 4. In this case, I expect that 2, 3, just 2, 3 should be returned. And I will take a look at this. So here, I1 begins with 0, and I2 begins with 0. And intersections is empty. So in line 53, yes, this is true, because both of the lengths are 1. And in line 55, start is, sorry. Oh, wait. No, this isn't correct. I have to take this. Yep. In this way, start is max of first list, index 0, 0 should be 1. And second list, I2, which is index 0 at 0 is 2. So this one, which is equal to 2. And here I get mini, and first wrist I want with this, and index one is 3, and for the second one it should be 4. So I get 3. So end is larger than start, so 2, 3 should be appended. And it should be the wrist. Okay. So now intersections has 2, 3. And in line 60, first wrist I11, which is 3, and second wrist I21, which is 4. So 3 is smaller than 4, so I move the I1. But here, I1 becomes 1. And in line 53, because I1 is equal to length first wrist now, so I go out of the loop and I return intersections, which is 2, 3. Okay, so as expected, I return 2, 3, interval only. So I passed this test case. Okay, that being said, I'm pretty confident in my code. Yeah, because I covered all the lines. Yeah, obviously I should have tested some cases like how this larger than end. Like there is an intersection like this and this. Or maybe in the similar way, I should test something like this case too. Yeah. And obviously I have to take care of the case when I move the I2. So maybe I need some case like this. And obviously I should keep continuing. I should continue the 2 pointers with 2 or more intervals in each wrist. Yep. So I think I can add these test cases in the real world development. But for now, I'm pretty confident in my code, so I submit. No. So I missed this test case. So let me think. I see. So 5, 5 is possible intersection. I didn't know that. So if in the case of this and this, yep, I should include this number. So here I can say in line 68, I add this equal. So now I've passed this test. First test case, I submit. Good, accepted. Okay. So probably I should have clarified that this is the intersection in the clarification section. Yep, anyway, let me quickly wrap up. So today I solved the question, interval wrist intersections. So in this question, I was given 2 wrist closed intervals, and my task was to find the intersections of the interval from the first wrist and interval from the second wrist. Or I should say any interval from the first wrist and any interval from the second wrist. And in each wrist, intervals are disjoint and sorted. Okay. So in this question, I use the 2 pointers. The first pointer is running on the first wrist and second pointer is running on the second wrist. And if I find the intersection, I append it to the returned wrist. And after making the intersection of the pointed intervals, I move the pointer, which is pointing to the interval which ends earlier. Okay, that's it. So that being said, I finished my today's coding practice. Thank you so much. Bye.